Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And hey, buddy, guess what I gave up today?
What did you give up today, friend?
Well, maybe not today, maybe last week, but coffee.
Okay.
Caffeinated coffee.
Really?
I have to drink decaf now.
Okay.
I found it was spiking my blood sugar.
Interesting that caffeine could spike your blood sugar.
So I don't know if it's just caffeine or if it's the amount of caffeine or if it was a particular brand of coffee, but all I know is I stopped drinking caffeinated coffee and my blood sugar went down to normal. It was, as you know, I've been type 2 diabetic for a while, but I don't have the symptoms of type 2 diabetes anymore.
Right.
Right. I have this continuous glucose monitor that goes in your arm, and it has a little device, and it takes a sample of your blood sugar every minute or so. And then when you put the device near it, it transfers all the data points to it so that you can see it in a graph.
Right.
And I found that normally my blood sugar is well under 100. It's 80s, 90s, sometimes even 70s and milligrams per deciliter. And then I fasted for a day, and then the next day I drank coffee. That's all I did. I just drank some half decaf, maybe 4 or 5 cups. By the middle of the day, it was 158. It's crazy. So I don't know if the caffeine was perhaps adding stress, and that was spiking it up. But all I know is that I switched to decaf, and everything's fine. So I'm getting old, my friend.
Yeah, it's interesting because, of course, there's arguments that black coffee even pulls your blood sugar down too. So,
yeah, I've heard that argument too.
Yeah, but you've got data for you. That's all that matters.
That's all that matters, right? Yeah.
Yeah, I don't know if fasting affects that. Like
fasting, if you're just fasting with water and salt, your blood sugar should drop.
Yes.
Yeah. And it did. But then,
yeah, it's interesting to think about whether fasting puts your body in a particular state where sugars are revealed. Like it's not like there's sugars in coffee.
No, it doesn't.
So it's like where is those sugars coming from that your blood sugar goes up? Anyway, interesting stuff.
Interesting stuff indeed.
All I've got is my dog turned 14.
Oh, did you have a party?
The bear hunter. He's an old man now.
Well, I thought I would bring up that testing because we're talking test automation with Arnon Axelrod. But first,
I love it.
Let's roll the crazy music for Better Know Framework. All
right, dude, what do you got?
This is a very cool project. It's called webgazer.js.
Oh.
Democratizing webcam eye tracking in the browser. So, yes, remember the eye trackers that were very popular a couple years ago?
I don't know if they were very popular, but there was a wave of them. But they were custom hardware you had to add to your computer to make it work, right?
That's right, and you had to calibrate them as well. And all right,
yeah.
Well, anyway, so this is a JavaScript library. It uses your webcam.
Interesting.
Yeah, and you go to webgazer.cs.brown.edu or just Google or Bing webgazer.js. You can actually do a real-time demo, and I would make sure that the lights are on. That's all I'm going to say.
And I got to think wearing glasses must complicate things. Like it's not some trivial thing to track eyes in detail, but cool.
Yeah. It's very cool. So, real-time gaze prediction on most major browsers. It does self-calibration from clicks and cursor movements, basically assuming that
presuming that you're looking where your mouse is pointing.
Yeah, your eye's going to follow your mouse, exactly.
That makes sense.
Couple lines of JavaScript, you got it.
That whole eye tracking thing was really about what are the hot spots on your site? Like, are people seeing your ads?
Now, that's a great idea. If you can use it in correlation with your pages to sort of map where people's eyes are going, that's a great idea. Yeah.
And our friend Kent Alstad has a new company he's been working on for a while now called Cloud Army, which is specifically about applying neuroscience to understanding people's behavior. And he uses it for market analysis, for doing things like understanding whether people care about a brand or recognize packaging, things like that. So, and rather than surveying them directly, this is actually studying people's behavior around it. It's complicated. Maybe we should have him on to talk about it.
Yeah, we should.
But he's big on the eye gazing thing. I think it's where people look. It says a lot about what they're actually thinking.
Wow, very good. We'll have to talk to him about that. All right, so that's what I got. What do you got?
Grabbed a comment off of show 1586 from October of 2018. We were talking to Patricia Ass about reading other people's code, which I think absolutely correlates with testing. And this great comment, which a few months ago, comes from one Arnon Axelrod.
Never heard of him.
Never heard of him either. It says, great show as always. Patricia gives some great tips and techniques for reading someone else's code. However, there's one key thing that I felt was missing from the conversation. When you read someone else's code, there should be a reason and a goal for it, and that this should be kept in mind, focusing your efforts and the overall shape of how you go about reading that code. For example, reading old code of someone who's left the company in order to make a small change to it is radically different from performing a code review to a colleague on a new feature. Besides that, I totally agree, and often claim that myself, that writing code is primarily a means for communicating between people, sometimes between you and yourself at some time in the future, and that only then a means to program the computer. Yeah. Otherwise, we would just write our programs using ones and zeros.
Yep.
Which is true. Yeah. You know, these languages that we use, they're just giving ourselves different ways to express our intent, which certainly the computer can respond to, but also other people reading the code.
Yeah. Yeah.
So thanks, Arnon. And a copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on Facebook. We publish every show there twice a week. And if you comment there and we read it in the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet because, you know, we look at them. We do.
So, yeah, read a comment from our guest.
That's right. And here he is, Arnon Axelrod. He's a senior consultant and leads the test automation division at Sela Group. Arnon started coding in the 80s on a ZX Spectrum when he was 10. And hasn't stopped ever since. In the last decade, he specializes in everything related to test automation. And for him, everything in the development lifecycle is related to test automation. So this includes unit testing, integration tests, and UI automation, automation tools, including Selenium, Appium, SpecFlow, and many more. The best practices for developing test automation, TDD, clean code, refactoring, DevOps, agile methodologies and processes, software architecture, and even organizational structure and culture. Can't leave that out. And Arnon writes about these topics in his blog, LinkedIn, and Twitter, and speaks about them internationally. He also teaches them and helps his customers apply them successfully to their needs. Welcome, Arnon.
Hi. Thank you for having me.
Thanks for being here. Enjoy your new Music to Code By for writing that.
I already have, and I used it when I wrote the book.
Oh, no kidding!
Nice.
Wow, that's so
cool. It
helped
me a lot. Yeah, and I even mentioned it in the acknowledgement. I mentioned you and on the Music to Code By in the acknowledgement.
Oh, the so book. Cool! Thank you. So, I guess the whole idea of test automation is just to make it invisible to the developer, as invisible as possible, is it? Or are we still requiring developers to write their own tests?
I think that developers should at least participate in writing the tests. In some teams, the developers write the test themselves, and I think it's excellent. In some other teams, there are different people that write the test from the people that write the code. There are different organizational patterns regarding who writes the test automation. I also have a chapter about it on my book also, which I think we didn't introduce my book formally.
No, let's do that.
Okay. So I just wrote a book called Complete Guide to Test Automation, published by A-Press. It's a very comprehensive book, 500 pages. Almost everything that I know about test automation. In fact, for everyone who's interested in test automation in any way, which should be anyone in the development team. This includes developers, the testers, test automation developers, of course, managers, architects, you name it. The first part of the book is not very technical. It's more, high level. It focuses more on the what and the why questions. rather than the how. And the second part of the book is more technical, where I show step by step, like a tutorial for how do I go about designing and writing a new testing solution. How do I write the code and how do I refactor it? Because I think that these are very important things when you write test automation. It's important to write it in a way that is very easy to maintain and is very reliable.
I'm glad that you brought up Appium, which is a framework for testing mobile apps. There are ways to automate that stuff in the cloud, automate things like Appium. Do you think it's necessary to use these cloud-based testing farms, or can we get by with running local tests on mobile devices?
Okay, so it depends what you want to test and why. I think that the first cycle of testing should be more the functional tests. And most of what I write in the book is about functional tests. In order to write and to run functional tests, you don't need to run it on every device. Most functionality should be identical, and also you don't have to test everything through the UI. You can test most of the things through API or through component test or even unit tests. So most of the functionality don't have to be tested on all devices. But after you have your functional tests pass, sometimes you want to test that it works correctly on many other devices, then it's beneficial. Though it's important to remember that most UI automation tools, Appium being one of them, don't actually test that the UI looks good, looks right, and is usable. It's not a replacement for usability testing.
Right.
So you have to keep that in mind. But I guess that there are things that can work good in one device and don't work well on another device in the functional level either.
Yeah.
And is that what Appium's going to show up for you? Is that this is not rendering correctly on this device?
No. So Appium, which is very much an extension to Selenium, which behaves more or less the same, only that Selenium works on the browser and Appium works on mobile devices. They reflect what's the elements that are shown on the screen, but not their layout. You can query the layout and ask where the position of things are, but you normally don't do that. It's not very effective to do that. So if a button exists, but it's not big enough, or the text is not clear, or even if the text is truncated because of the size of the button, Appium and Selenium won't tell you these things.
Okay.
There are other tools of visual testing that do that, but they are more oriented towards comparing the images against previous images, which is good to some extent, but it also has a drawback that in order to maintain the images of the old versions, it can be a lot of work if something changes in the UI, especially if something changes through the UI across the board.
All those images have to be reshot then.
You change the font in all of the screens, then you have to record again, take the snapshots again.
Are there any considerations for testing microservices that might not seem obvious?
Typically, you test it by sending REST calls and get the responses and assert that you received what you want in the response. But it depends on the application and the architecture of the application, and again, what you want to test. I have also one of the chapters in my book, one of the bigger chapters, is I'm talking about the architecture, the relationship between test automation and the architecture of the application.
Yeah.
So you have to consider your entire architecture and also consider what you want to test, and then decide what components, what services, or what any component that I need to include in the application under test and what I can use mocks or simulators.
Right.
And I don't want them as part of my test because they can make my test less deterministic. I don't have control over them or more slow. There are many aspects, many considerations to this. So some people say I have this and this microservices. Each microservices has to have its own test, but it's not necessarily so. In some cases, it's better to test few services together. In some other cases, you can use unit tests or component tests to test just part of the microservice.
That's one of the promises of microservice, right? Is breaking things up into testable units. Not just testable,
yes, but you can also break things up to testable units if you just build your code in a modular fashion with
right.
classes and DLLs. You can build a modular application without using microservices. Microservices is good for scalability and for more dynamic deployment. But you can build a very modular application and very testable application, which doesn't use microservices.
When you're thinking in terms of test automation here, is there sort of a spectrum? Like, is there only one? I'm presuming there's not a big red easy button and boom, we're test automated. Like, what are the first steps in automation that you need to take, and how do you know when you've gone as far as you can go?
There are a few things that you have to look at before you even start to choose the tool and let alone start writing the code. You have to look at what the application does and what's important to test. Then look at the architecture. You also have to look at who's going to write and maintain the tests. These are, I think, most of the more important things. Then you need to decide about the architecture of the tests and how the tests interact with the application. You can have one solution for this, but sometimes you have different kind of tests for different problems. So as I said, you can have both unit tests, integration tests, and system tests, for example. This is the first things that you have to consider before you even start considering the tools and how to write the code.
Right. Do you find there's software architectures that are resistant to testing or very hard to test?
Yeah, if the application is written in I want to say monolithic, though today when most people say monolithic, they think about something that is not microservices. But
right,
as I said before, it can be a monolith in terms of microservices, but it can be very modular in the way that it's built.
Right.
So applications that are really written as one, spaghetti of dependencies.
Web forms
and
code behind
something that it's hard to break to smaller pieces. And also, if the UI technology is not all UI technologies are very friendly to UI automation. So in these cases, it can be very hard.
Yeah, and you see folks using that as an excuse just to not get into testing because it's so brittle and so difficult and it can't get to the depth. You actually understand what's going on there. Does that put the onus for writing tests on the devs? Or do you still see separate QA departments these days? It seems like Microsoft's gone away from that.
Yeah, I still see those teams, though less. I gave a talk both here in Israel and in Lithuania about test automation maturity.
Oh.
I categorized 5 levels, and one of these levels is separate QA teams from the development. But when I started to work as a consultant 4 years ago, it was much more prevalent, and these days it's much less so. I see more and more companies going towards unified teams, and sometimes into teams where everyone does everything. The developers participate in the specification phase, and of course the design architectures, write the code. They also test their own code, and they also monitor what happens in production and see the actual results.
So let's dig into these 5 maturity levels of organizations that are adopting test automation.
So the first level, I call it the naive level, because the main question here is, how hard can it be?
Yeah.
Some teams that before they start using test automation, they either think, sometimes it's a manager that thinks, I'll just send my QA team to learn a little bit of programming, and we'll teach them a tool, let's say Selenium, and they'll write my test automation. Sometimes it comes from a manual tester that takes his own initiatives and decides to start writing test automation. And again, he thinks, how hard can it be? And he starts. And in the beginning, he sees that it works and is very happy, and he shows it to his manager, and his manager is maybe very happy, but it doesn't hold for very long because he doesn't have the skills to write maintainable, stable tests, and every other day the tests break, and it takes longer to stabilize them and to fix them than it takes to test it manually. So this is the first level.
And I've certainly dealt with organizations who are in that place where literally when V2 of the product came out, we had to throw away all the tests we've written and write them again. Are we writing tests the wrong way?
Probably.
The point is, tests shouldn't be that brittle.
Yeah, it shouldn't be that brittle. It depends on how, if the tests are written only in a technical way, they test technical aspects of the application, then if this technology changes, for example, then this test should be rewritten. Mm-hmm. By the way, one disadvantage of smaller tests like unit and integration tests, where system tests are less brittle to these kinds of problems. Though, of course, the UI technology can change too.
Right.
But so it's not only that; it's also what the tests verify. So if the tests verify the behavior of the application, let's say in business terms, like add a product to the inventory and sell the product, and if you're using this kind of terms, then you can change the implementation of some methods maybe a lot of methods, but you change only the implementation of some methods in the test automation, but the tests themselves can remain more or less the same.
And now we're describing tests that are much more about the intent of software rather than the implementation of it? Mm.
Yeah, exactly.
Okay.
By the way, tools like Cucumber and SpecFlow, which fall under the category, people like to call them BDD tools, right. Though BDD is more a methodology rather than the tools. But these tools guide you to write the tests in a textual manner that describes the business functionality of the application rather than the technical details. Of course, the tool itself cannot force you to do the right thing.
Right.
So many people use these tools, but the sentences they write are very technical. So you also need to use it correctly.
Yeah, but I appreciate a tool that sort of helps you fall into the pit of success here, rather than you go off on your own and just go the wrong way. We've talked about Cucumber and SpecFlow on the show before, but I think it's literally been years.
Yeah, I so too.
Since we brought it up, so I appreciate you mentioning that. But that moving to that sort of next stage of maturity, is writing better tests part of that equation?
Okay, so let me go through the other levels. So the second level is what we talked about before, which is the QA-centric, where the test automation is perceived to be a responsibility of the QA team, which is a separate team in this stage. But in this stage, The test automation itself is more mature. There's at least one dedicated automation developer, sometimes a team of automation developers. But the perception is that their goal is to find bugs, and when the bug is found, then they file a new bug. And if the bug is critical, then like any other critical bug, it's fixed immediately. But if the bug is not very critical, then you file a bug and it can be fixed somewhere in the future, whenever the developers will have time, 2 months from now or whatever.
After this current sprint, like if it's a rendering problem on a minor device, you're just not going to prioritize it.
Yeah, but even it's in the next sprint, it's better. But in some cases, many companies still work in a water scrum way,
like Scrum fall.
Internally you do Scrum, but you release the software to the customer only once every 6 months, for example.
Scrumish.
So only the few sprints towards the release, these are the stabilization sprints, and only then you fix the bugs.
Right. I get it. And I think we're just sort of walking around this, that test automation is part of a DevOps practice of doing continuous delivery, that sort of thing.
It's very related. I think that DevOps is more applicable to SaaS products, web applications or web services, but not all applications in the world are
where you're not doing installations on client machines.
Yes. Medical applications that they have to go through FDA verifications, and so not everything is just a web application that you throw out and immediately everyone sees it.
And everybody's always on the latest version. Like you just don't. You live in the web world. You just lose track of the fact that in the deployed world, people are running old versions of your software, and you can't stop them really.
Exactly.
Yeah, it's an interesting problem just dealing with that. But maybe we should have addressed this right off the bat. What is automation getting me if not going down this continuous delivery pipeline? Like, why do I want to automate?
Okay, so it is about continuous delivery, though in those cases where you release the product only once every few months, then it's more as an internal process, like let's say continuous integration rather than continuous deployment. But it's also very beneficial there because you can work internally where every sprint you add a little bit of value to the product, and you prioritize to start with the more important features at the beginning. And if things aren't going the way you planned it exactly from the beginning, at least you can deliver something on the time you decided to deliver it, and it's in good quality, and it works, and it gives a lot of value to the customer still.
Yeah, absolutely. And I hate to keep going off on these different trails as we work through the maturity model, but I just think these trails are super interesting too. It's like, these are the problems you're going to run into.
Yeah.
So we've got some folks that are now thinking about automation all the time. I would imagine they're often QA folks, but do you find there's just like certain developers on a team that they got a knack for automation and that's what they tend to work on? Who is the person leading your automation effort at this point? Is it a dedicated QA person or is it a developer?
So it's typically a developer that belongs to the QA team. It's a test automation developer. Sometimes it can be someone who was a manual tester but has some more programming knowledge. Typically in this level, you don't use very, let's say, expensive or junior developers. Companies try to hire people, more juniors or testers that have some programming background.
Right.
So I know a lot of developers like to automate everything. Automated deployments and deliveries and automated testing just should be part of that.
Yes, of course. Test automation is part of the test of the automation of the deployment and of the integration and everything. But it requires different skills and different mindset. It's not just automating the process, because tests are a little bit different than just automating a process. So the problem in this QA-centric level is that the maintainability and stability are handled, but there's still a struggle, there's still a challenge, and the collaboration with the developers is not very good at this point.
Mm-hmm.
And in fact, the feedback loop is very long.
Right. And this still sounds, you're like we're pressing against the edges of a DevOps conversation again. I want those shorter cycles. I want people to see things quickly. I just really am enjoying your approaching this from a test automation perspective. So keep moving. Next level.
Mm-hmm.
Okay, so the next level is collaboration. In this level, the test automation developers and the application developers work in the same team, or in the same Scrum team at least, and they work more closely together. Here, if test is failing in the nightly build, it should be fixed the next day. But it's typically in this level, these are still different roles. The role of the test automation developer and the application developers, and they're starting to collaborate, but it's still not full collaboration. They don't often do code reviews to one another. If the test automation breaks and the test automation developer is on vacation, then maybe they'll wait for him to return in order to check what happened and so on. And also the test automation that is developed here is more the end-to-end test and less unit tests or integrations. Sometimes there are unit tests in this level too, but the developers write the unit test and the test automation developers write the system test, but they hardly talk to each other about what do you test here and what do you test here. So they start to collaborate, but it takes time until this collaboration really matures.
Are there particular practices that get them to collaborate better, or is this just come with experience?
I think that first of all, it's an organizational decision to start working in the same teams, that the test automation developers and the developers of the applications start working in the same team, or at least use the same Scrum teams. But also in this level, oftentimes the test automation developers write the test automation only for the features that were developed in the previous sprint.
Right.
So it's a little bit of like a mini waterfall. So regarding bugs, the feedback loop is much smaller, but regarding the development of the test automation itself, they develop it one sprint after the developers, and it's still hard to get them to fix or change something in order to make it more testable.
Right. And I think that's a very interesting feedback, and having the devs involved in the testing is important, because then they realize how hard their code is to test.
Yeah. So the first level is what I called fusion, and here the collaboration is really tight. Here you'll typically see either one team that everyone is a developer or an engineer. As you mentioned, Microsoft these days work in this fashion.
Yeah.
So everyone plans the test, right? Implement the test, execute the test, and this is almost as far as test automation maturity can go, though still typically bugs, are just a way of life. But here the team's starting to think and strive towards getting into zero bugs, at least zero bugs mindset.
Do you see that as actually achievable?
It depends how you define it. I think that it's more of a mindset, but I think that it's achievable that if you prioritize fixing any bug, every bug as quickly as possible over adding new functionality.
Right.
And you also do root cause analysis for every bug and try to make things to prevent similar bugs from occurring. It can be not only by changing the code, it can be by changing the way we work, some procedures or things.
And the key part there is root cause analysis, not just fixing the bugs, but trying to figure out how we got them in the first place.
Yeah, exactly. So I think it's very challenging. In fact, the fifth level, which I'm going to talk about now, I don't know any team that really works that way exactly. Mm-hmm. But I saw teams, and I used to work in a team that was very close to this. So I call the fifth level the encompassing level, because here the test automation is not only for testing, not only for verifying functionality, but it encompasses the entire development life cycle. And this is where the BDD we mentioned before, or I like to call it ATDD, acceptance test driven development, which is very similar methodology. This is where it kicks in. In this methodology and mindset, the team collaborates. Let's say typically, most developers think that the product owner should describe the specification of the new feature that they want. Mm-hmm. This is what most developers think of when they think about a user story. Mm. But here, I think about a user story only as a definition of a problem. You know, the 3 sentences: as a role, in order to something, I want, blah, blah, blah.
Right.
You know this format of user stories?
Sure do.
So I say that the product owner should only write the first 2 sentences. As a role, in order to, that's it. What I want is already the solution to the problem. And I think that the team should collaborate on, the product owner should come with the problem and discuss with the entire team what should be the best solution to the problem.
Sure. Now, I got to think the guy owning user stories knows what he wants the answers to be, but he's leaving room for other people to present other ideas there.
Exactly. So he can suggest his own solution, but...
Sure. But making it a suggestion is way better than dictating what should be done.
Right, and builds up the team's confidence and grokking of the problem.
Yeah, exactly. So the team decides collaboratively on the solution, and then they define the acceptance criteria for this solution.
Right.
And when they define this acceptance criteria, they define it in a manner of an example, a usage example. So the user does this, and this should be the result. So This is already a definition of a test. Mm-hmm. And when it's done collaboratively, it's easier to find gaps in the understanding of different people in the team. Because when we talk, in general words, sometimes I can use one word to mean one thing, and you can use the same word to mean another thing, and we both sure that we both understand each other. But when I'll go and implement it, I'll do one thing and you'll think that it's completely different from what you thought. So when you talk about examples, concrete examples, it's easier to spot these gaps.
Well, and getting back to your whole point about the root cause analysis, how often do we find our real root causes they didn't fully understand the problem?
Yeah, exactly.
Yeah. And so going through this process to help them really understand the problem is kind of a key part of it. You're stopping bugs with that activity. They'll never get written.
Exactly. So now you have the definition of the test. You can automate the test even if the application is not written yet. Now, of course, you can decide collaboratively also which kind of test should I write in order to test it? Should it be an end-to-end test or a unit test? And then you implement the test and implement the code that makes this test pass, like in TDD. But the great thing is if you do it from the beginning of a project or early enough, then by definition, you have full coverage of test automation on every feature you ever developed.
Yeah.
And this coverage is not only just a metric of code coverage, but it's also the coverage of the user stories of the real solution to the real problems of the customers.
I get it.
Mm-hmm. Yeah, I'm wondering how often those user stories end up being expressed in this sort of accepted-driven test model comes into really describing a business case anyway, and a business value proposition is the metric of a pass.
Yeah, exactly. So if you have full coverage and full coverage of very valuable tests, not just technical tests, then you can easily refactor your code and you can get rid more easily of technical debt. Or let's say if you do it from the beginning, you can avoid having any technical debt.
Yep, and that's what you want.
All the time you can continuously refactor your code to make it the best possible design at every given moment.
Yeah.
And this also prevents bugs. When the design is good, many bugs caused by bad design. And it's very hard to keep the design good when the requirements change. And requirements always change. So you need to refactor in order to keep your design and your code clean and easy to maintain. And if you don't do it, there are more bugs. But if you do it, and if you have full coverage of acceptance tests, then you can do it very easily and very safely. And continuously refactor your code to keep it clean and with good design.
Sounds like a worthy goal. Tough to get to, though.
Yeah, very tough.
Well, Arnon, we wish you a lot of luck with your book and in the future, and thanks for spending this hour with us.
Thank you. Before we wrap up, I want to let you know that listeners of this show are eligible to a discount of my book. If you go to apers.com and type the discount code Test Automation, you'll get 20% discount.
Oh, thank you. That's very generous. I'm sure you'll get some sales off of that.
Thank you.
You're welcome. And thanks again, Arnon, and we'll see you, dear listener, next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC. Yes, I'm a